Hey math kids, today we're going to be in section 4.AD and we're going to talk about conditional probability. So we're going to start with this math statement. So the way you pronounce this is A given B. So the probability of A given B, and then this would be A and B, and this is just B. Okay, so the probability of A given B, probability of A and B, and then the probability of B. Now what this means is if we had a Venn diagram, and we have A, we have B, if we know that we're only inside of B, we want to know what probability that we're also inside of A. So we kind of reduce the problem to this situation, where we call this B, this is a piece of A, and we want to know the probability that this will occur knowing that we're inside of B. Okay? And so this really is just going to show up in a bunch of story problems. So I'll read these to you and write down the important information, and then we'll go from there. Okay, so it says, Jimmy notices what seems to be a pattern in his math teacher's outfits. He wears a polka dot tie 30% of the time. So that's a tie. And 40% of the time, he wears a brown suit. So, suit. And then notices that 20% of the time, the teacher wears both. So most of these problems are going to be set up like this, where one thing's happening, another thing's happening, and then they're both happening. And kind of what we use in our formula relies heavily on the last sentence. Often it's the last sentence. So it says, what is the probability that he is wearing a polka dot tie, so wearing a tie, on a day he is wearing a suit? So we want to know the thing that's happening for sure. So I'll read it one more time. What is the probability that he is wearing a polka dot tie on a day that he is wearing a brown suit? So we actually know that the suit is happening, and so that's going to be our P of B. The thing we know is happening. Now if we go back to that formula up here, we just need to know the both divided by the P of B to figure out the other part. So all we're going to do, we're going to take our both, divide it by our P of B. We actually don't even care about this one. And so we say 0.2 divided by 0.4. We can plug that into a calculator or just think about it a little bit, and we'll see it's 1/2. So 0.2 divided by 0.4. My calculator's frozen. So 0.2 divided by 0.4 gives us 0.5, or a 50% chance, or a 1/2 probability. Okay? Let's try one more. Tim surveys his gym class and determines that 20% have spider robots, and 40% have pig robots, and 10% have both. If Tim asks a random student who has a pig robot, if he asks a random student who has a pig robot if they have a spider robot, what is the probability that they would say yes? So this is asked a little bit different, but let me read it one more time. If Tim asks a random student who has a pig robot if they have a spider robot also, what is the probability that they would say yes? So from that statement, we know that pig robot is what they have. So that's our P of B, or the bottom of our thing. We don't care about the spider. We put both divided by that, so 0.1 divided by 0.4, which is the same as saying 1 over 4, which would be 0.25, or 25%. Okay? That's everything for this video. If you need additional help, come to Math Lab. Until then, calculator.